Now it is my honour to invite His Excellency Minister Suhail Mazrouei, UAE Minister of Energy and Infrastructure, to the stage for his opening remarks.
Excellencies, ladies and gentlemen, good morning. It's so exciting to see this number of professionals, ministers and vice ministers, industries visiting us in the UAE, participating at the world's most important event, looking at the future planet Earth and ensuring that we will make living on it sustainable, and we will clean the emissions and ensure that we are leaving the planet at a plan for a better shape for the future generations. We were one of the new nations to nuclear energy, and what an experience we had. Since we started, many have been puzzled why would a fossil energy-rich nation with abundant resources think of nuclear energy. And the drive was the visionary leadership that believes in the sustainability and believes that any finite resources, you need to have a plan for reducing it, especially if emissions are associated with such a source. Today, with a collaboration of 22 nations, we proved to the world that they need this industry. They need it to stay, they need it to thrive, and they needed to compete. And I am sure that the prices we see today for producing nuclear energy will be reduced significantly with your efforts, because the world have now come to a realization that we need to triple the capacity of nuclear energy by the year 2050. That amount of business that is going to be available for the companies, I have no doubt that economy of scale will reduce the prices and will make nuclear energy competitive. Today, I still believe that it's the most reliable, clean baseload in the world. And as we move to putting prices on carbon and move into capturing CO2 emissions from other sources which emit CO2 and put the right cost for it and apply that to the price, we will easily see that this industry is already competitive. But the race of cleaner molecules and cleaner electrons is going on. I remember 10 years ago when we installed the first CSP, solar CSP plant here in the UAE. The cost was north of 32 cents per kilowatt hour. And look at it today, yesterday or the day before yesterday, His Highness Sheikh Mohammed bin Rashid inaugurated the 4th phase of Mohammed bin Rashid Solar Park with a price of less than 7.5 cents per kilowatt hour for 24 hours of electricity using molten salt or some form of batteries. So that race that dropped the price from 30 plus 10 years ago to less than 8 is going to be the same race and the same opportunity that hopefully will make nuclear energy in the future much safer and will tackle some of the challenges we see today, among which the price. We in the UAE are open to looking at opportunities not only in the UAE but even worldwide to invest in this industry, because we believe that the world needs it, and we believe that industries needs it to ensure that we reduce the emissions to the level of 0 by the year 2050. I wish you a candid, frank, and looking forward a discussion and looking forward for your deliberation, because what you discuss here is very important in shaping the future of this industry. Thank you very much for participation, and we look forward to grow the number of participants in this initiative of tripling the capacity of nuclear energy to the level it deserves. Today is just the beginning of 22 countries. I am sure the number will increase as the world believe in this industry. Thank you very much.
Thank you, Your Excellency. I'd now like to invite David Victor, Professor of Innovation and Public Policy at the School of Global Policy and Strategy at UC San Diego, and Staffan Qvist, Researcher and CEO of Quantified Carbon, to the stage to set the strategic perspective for global demand.
Well, thank you very much, Excellency, Excellencies, citizens concerned about how to clean up our energy system. Staffan and I want to take about 25 minutes and talk about the larger picture, show you some data, and in particular we want to talk about the staggering scale of the challenge here. And the word staggering is chosen with a reason. It is very, very easy to make pledges about cutting emissions. This is some work from the Financial Times that's looked at pledges by companies on the left-hand side, and the time horizon over which that they have made these pledges. Companies are getting good at making pledges. Governments are getting good at making pledges. We see this over these weeks during this climate conference. But the question is, how do we deliver on those pledges? And that's what we want to talk about today. And the scale of the effort is truly staggering. So what Staffan and I want to do over 25 minutes, and then we're going to have some time for questions and answers, so already get your questions ready, is we want to talk about really three things today. One is we want to talk about the driving forces, what explains the staggering need for clean electrons and molecules, the theme of this conference for the next 2 days. Second, Staffan's going to come up and talk about a couple of industries. Every industry is different, but the messages rhyme across the different industries, and we'll talk about what that means for electrons and molecules as we actually move from pledges to serious action. And then I'm going to come back up and I'm going to talk about how do we get it done. What should we be looking for over the next 2 days? How do we take these ideas and turn them into a reality? So first, I want to talk about driving forces. What explains why we have this staggering need for clean electrons and molecules? And when you look at the data are just extraordinary. So first thing to understand is what explains why the world needs clean electricity and molecules. It is not just the demand for zero emissions. That is absolutely paramount. But in addition to that, economies and populations are growing. When most of the people in this room, including me, first learned about the environmental crisis, we learned about this as a population problem. Today, frankly, people are not talking very much about population. In fact, serious people, myself included, are talking about concerns that we won't have enough people, at least enough young people, to sustain the vibrancy of our modern economies. The number one driving force in every region in the world, and these are data summarized from the latest World Energy Outlook from the International Energy Agency in Paris, the number one driving force for growth in emissions is economic growth. We want economic growth. We want to expand welfare and opportunity for people. The challenge is how do we decouple that economic growth and the opportunity to make economic growth even more vibrant? How do we decouple that from the activities that cause climate change, the pollution of carbon dioxide and other greenhouse gases? So, one way we do this is with electricity. This is some work that Systemic, working with the Energy Transitions Commission, has done. I'll say a couple words about other studies in just a moment, that shows the demand for clean electricity in 1,000 terawatt hours per year from where we are today, roughly today on the left-hand side, up to a future of net zero emissions by 2050. By their analysis, we could have a rise in demand of 3.5 to 5 times from current levels. That is staggering. About 2/3 of the effort needed to cut emissions to zero is from clean electricity directly. And maybe 1/3 of the effort, nobody really knows. That's one of the reasons why we have to run experiments. We have to learn. About 1/3 of the effort is from clean molecules. And when Staffan gets up here, he's going to talk about some different industries and the interaction between electricity and molecules. It's one of the most vibrant and exciting opportunities. But just pause for a moment on the number. 2.5, 3.5 to 5 times current levels of production of clean electricity. And in some cases of clean molecules, hydrogen, for example, it's essentially infinite because the production today is almost zero, and the production in the future could be really, really high. One of the things that's interesting about this study is if you look at the middle bar, this is what happens if you assume aggressive efforts at energy efficiency. Everyone's talking about energy efficiency, that's great. We have to work on energy efficiency, but even with a lot of energy efficiency, there's still a huge increase in the need for supply. That's one modeling work, one set of modeling work. McKinsey's work suggests at least a doubling of demand of supply for clean electricity. The IEA's work is 2 or 3 times. EPRI is represented on the group on the panels here. EPRI's work is showing 2 or 3 times. A message that's now coming across all of these different studies. When you look at the demand for clean electrons and clean molecules, you see that in different sectors, this is ammonia, aviation, steel, trucking, the list goes on from there. On the right-hand side, this is the fraction of global electricity demand that is going just to that sector. So the kinds of things that Staffan's going to talk about in just a moment really matter when we think about what's driving the demand, the staggering demand for clean electrons and molecules. So what I want to do now is I want to turn the floor over to Staffan, who's going to talk about a couple different industries, and I'll come back and talk about how we get it done. Staffan.
Thank you, David. He'll come back. So I just wanted to give you a couple of snapshots of sectors and what their decarbonization journeys would entail for the demand for clean electrons, clean molecules that we're talking about here. Now, obviously, we have a lot of fossil-fueled electricity generation. Turning that into clean electricity generation is quite obvious. There's also sectors that are currently using a lot of fossil fuels that will need to go electric. That is kind of, in a meeting like this, a lot of people disagree on a lot of things, but one thing that is almost consensus, converging on consensus, is electrification is probably the main pathway towards decarbonization. So I don't, unfortunately, have the time to talk about all of these sectors, but I'll touch on a couple, and hopefully there's some new information, and it will ideally give a sense of the scale of, depending on how you look at the world, the challenge or the opportunity. I'd say it's both a challenge and an opportunity. So iron and steel is the first thing I want to talk about because I'm heavily involved in it and I understand it quite well. Iron and steel is somewhat underplayed, I would say, in terms of the decarbonization challenge and its emissions impacts. So there's a lot of critique, some of it may be warranted, about people flying to these kind of meetings in private jets, maybe, 80,000 people coming here, and all the emissions of aviation. But actually, iron and steel as a sector dwarfs all aviation, all shipping, all rail, all transport essentially except for personal vehicles. combined. So it's 8.5% of all emissions today. And so I'm going to try to explain briefly what the process looks like to turn iron ore into steel today, and what it could look like in the future, and what does that entail for maybe the role of nuclear energy and the role of clean energy and the role of clean molecules as well. So today in primary steel production, we dig up iron ore, hematite or magnetite, which critically is iron connected to oxygen. And the main challenge, the main step that we have to solve is to get the oxygen off the iron. Because oxygen and iron connected is also known as rust. You know, it's quite a useless material. The main challenge is to get that oxygen off the iron, and through a few more processes turn it into steel, but those are less important. The main process is to get the oxygen off the iron. One thing that really likes oxygen, obviously, is carbon atoms. The main challenge is carbon and oxygen form a molecule that we are not so happy about anymore, which is CO2. So in many of the pathways and many of the trajectories that we're talking about, we want to use less material, we want to be more effective, we want to recycle more, and that's also true in steel, but steel is underpinning literally everything we're doing and all decarbonization plans that we have. Steel will be critical and is critical in essentially everything humans do. So there is a projection, even with all decarbonization, all efficiency, all recycling, that primary steel demand, that is taking iron ore and making it into steel, will increase, as well as secondary steel demand, which is recycling scrap metal. So the process today, and I won't go into any detail of any of this, but essentially we dig up, for primary steel manufacturing, we dig up iron ore, hematite usually, magnetite in my country, Sweden. You can turn that into fines or pellets. That has some energy consumption. Typically you burn oil for that process, and then the main culprit in this, it's the main building block of civilization, so I wouldn't say a culprit, but the main emitter of CO2 is the step, it's called a blast furnace, where we try to get the oxygen off the iron. So this is done by a fancy, very high grade of coal, and the coal snaps up the oxygen, makes CO2, but gets you metallic iron. And that metallic iron can then go into a basic oxygen furnace, which also releases CO2, and at the end you have steel. The problem here is we need a lot of steel, and to make a ton of steel, we release in this process about 2 tons of CO2. So that makes these primary steel 8.5, well, something like 8 to 9% of all CO2 emissions. So what can we do about this? There are a few pathways. I'm going to tell you briefly about the main one that's being explored. I'd say there are 4 credible pathways to doing this. One, obviously, is to put carbon capture on each of those steps, capture all that carbon, and then you kind of make blue, low-carbon steel. But green, meaning no carbon capture, but just clean from the beginning, could look like this. This is something that's being proven out. The technology has been proven, all the steps are there, but the challenge is the supply of clean energy, and I'm going to try to explain how big that challenge is. So instead of, in the pelletization process here, using oil, we can use bio-oil, or maybe even burn hydrogen for this step, not very important. The furnace that was a blast furnace using coal is now using hydrogen for reduction. So carbon likes oxygen, likes to make CO2. Hydrogen also likes oxygen, but out comes steam, which is much better outlet product, and that also is recycled in this process. Instead of using a basic oxygen furnace, this material then goes into an electric arc furnace, which, as the name suggests, just uses electricity, and out comes steel. There is a bit more to it than this. If there's anyone in the steel sector here, you can point my finger at me and say, for example, you don't have any carbon in here. Steel is obviously iron and carbon. It's more complex like this. But really, to summarize this, the challenge here is not these steps, not the technology of developing these steps. It's the supply of energy to make this process happen, and it's primarily the middle one. So 52 kilograms or so hydrogen to reduce iron ore to make a ton of steel. If we multiply out the energy demand for that, the total energy demand of the process I just shown to make 1 ton of steel is about the average human's electricity consumption for a year. So to make 1 ton of steel in this process, this decarbonized zero emissions process, takes as much electricity as the average human being on Earth consumes in a year. If we multiply it out by our expected consumption of primary and secondary steel, in the units of nuclear reactors, which is, an appropriate unit for today, that's 680 large reactors running continuously for just the primary steel from ore, just to make the hydrogen and heat the hydrogen, because the hydrogen furnace is endothermic, it consumes energy, so you have to heat the hydrogen as well. 680 large reactors for that, and 110 large reactors just to run the electric arc furnaces for the secondary steel. So, going back to the wonderful pledges we've seen, this sector transition alone, if powered by nuclear, would require a tripling of current nuclear capacity, so 3 times what we have today. So there are these kind of transitions all over the place, but this one is quite large. Another one, well, actually let's put it in the context. So these are the main power-consuming nations of the world. China leads almost 9,000 terawatt hours a year of electricity consumption. If we would make all iron and steel making fully green, so no carbon capture, just green from base, 100% green iron and steel would be the second largest country in the world. If we would do half carbon capture, or maybe have less steel demand than I'm projecting, we would be somewhere on the order of the US. If we would only do a quarter, we would be on the order of India. So these sector transitions that are maybe a little bit hidden in discussion are enormous. And they are enormous challenges, but also enormous opportunities. Another one that no one could have missed, I guess, is the growing demand for clean electrons. So this was a clean electrons to clean molecules case, the one with steel. This is a pure clean electron case. The rise of data centers and primarily the rise of AI, which has just only begun now. You can see the major data center companies having a 30% year-on-year electricity increase, demand increase currently, and that is not slowing down as far as we can see. So data center electricity consumption is doubling at a rate of less than 3 years now. How this will progress is a bit difficult to say because it's also becoming much more electrically efficient to run data centers, but the trajectory is quite clear. So we're currently globally adding about half of a United Arab Emirates of electricity consumption in just data centers driven by AI. And obviously, we have all just kind of started using AI. So we're at the foot of the hill, let's say. So if we put this one in perspective, the projection for 2030 is about 1,000 terawatt hours a year for just this little, it's not even a sector transition, it's a new sector developing, inevitably will develop because it's too useful not to. So the data centers on the high scenario, 1,200 terawatt hours a year, adds another Russia to our global power consumption. The central scenario, somewhere between Russia and Brazil, and even in the most pessimistic scenario, we're adding more than a new Germany, and that's in the next 7 years. So these sector transitions are huge, I would say, both opportunities and challenges, but given the leadership shown by the UAE, both hosting this meeting, building Baraka, I feel like we can probably rise to this challenge. And there's enough, the pie is large enough for renewables to meet their tripling, nuclear to meet its tripling, and actually the pie is probably quite a lot larger than that in total. So I'll hand it back to David.
Thank you. Thank you very much, Staffan. It's a big pie. It's a lot of pie. Enough pie for everyone. We want to close by talking about how we get this done. It's easy to talk about this issue. It's easy to pledge. How do we turn it into reality? Staffan and I have a list of 5 things. I'm sure all of you have your own lists. Over the next 2 days, tell us what's on your list. But I want to talk briefly about the 5 things on our list, which is here, and I'll put it up again at the end. First, we really have to understand what works. And in this business, what works, where the need for clean electrons and molecules is scale, is what's actually scaling. This is a terrific study that Radiant has organized that ranks since 2017 the countries that have put the most to clean electricity on their grid systems. Number 1 is actually the Emirates. Why? Because it's a nuclear story. Most of that bar there is green, the nuclear bar, plus a lot of solar, as we heard about from the minister earlier. Every country's different, though. Australia's got a story that is a wind and solar story. Finland has a story that's a nuclear story and a wind story, and on and on and on. Only 4 countries in the world right now are on track to be adding clean electrons at a scale consistent with the typical projections for net zero. So that's a reminder that where the ratio of pledging to doing is very high in the world, and we need to fix the denominator in that equation. That's one. Second on our list is we need to think about public support, and in particular around nuclear power. The old story that the public does not want nuclear power is wrong in most of the world. Here are new data, also from our colleagues at Radiant, that are being released roughly today, from a survey that was done over the last 6 weeks, just finished about 2.5 weeks ago. And it shows public support by country. In a lot of the world, public support is decisively in favor of nuclear power. Some countries not so. You know, Japan has been through quite a lot. But even when you look inside the data, what you see is a really big difference between older generations, like my generation, and younger generations, which we're going to be talking a lot about in particular tomorrow, where you see, even in a country like Japan, even in Germany, you see a big difference between older generation and younger generation, with younger generation being more supportive. And that's true for a variety of different surveys that have been done around the world. So the second of 5 is we need to focus on public support and sustaining public support, because that's part of the theory of change here. The third thing is I want to talk about is about the reliability of grids. Staffan and I and Mohammed Al-Hamadi have a paper out from Oxford Institute for Energy Studies about 2 months ago that looks at the experience in the Nordic countries and looks at the experience in Britain around adding renewables to the grid. There are big technical challenges here. These technical challenges can be addressed, but not if we pretend that they do not exist. Integration of inverter-based resources, most renewables, and interties, DC-based interties. One of the impacts of that is that they destroy inertia on the grid, spinning metal. And spinning metal is one of the key sources of voltage stability, frequency stability, and reliability of these grids. We have to deal with these kinds of realities. We can imagine science projects that create synthetic inertia. We need to invest in those science projects, but there's a difference between science projects and keeping the lights on. And it's very, very important that we recognize you need a diversity of sources to deal with challenges like inertia and grid reliability. And this is one aspect of grid reliability. Macro grids across multiple regions are another aspect. There are many other dimensions to this question as well. The fourth of the 5 is we have to mobilize investment at scale. So let me show you some data here from the World Energy Outlook that just came out earlier this fall from the International Energy Agency. And what this shows is that the investment story in the advanced countries is roughly flat. We need to increase investment in the advanced countries, places where we know how to deploy large amounts of capital. We're doing that actually already to some degree, and we need to continue doing that. The picture in China is also actually relatively flat. One of the great uncertainties about the future is what happens to the Chinese economy because of the structural weaknesses in the Chinese economy. But the big story is here, the emerging economies, the places that frankly have already not been that successful in attracting investment in clean electrons and clean molecules. And this is a reminder that if we are going to do this, if we are going to rise to the challenge here, it's a reminder that this is a massive investment challenge, and some of our most important energy policies are actually not energy policies, they're investment policies. They have to do with fundamental questions around the ability to attract and deploy capital. Clean investment is in fact booming. These are data from the Bloomberg New Energy Finance that every March or so comes out with a big survey on the state of investment in the world. Last year we saw for the first time more investment in clean energy than traditional fossil energy. That's good news. But what's interesting about the data is the global data are now nearly $1.2 trillion per year of investment in clean energy, but they're dominated. 85% of that money goes into solar, wind, and vehicle electrification. Why? Because that's where the technologies and the policies are most mature. But the lesson from everything that Staffan and I have told you about today is that if we're going to rise to the staggering challenge, we're going to need a diversified investment that is more than just investing in things we know how to invest in. We have to diversify that investment picture. So I want to just close and put the 5 up here again, and close by saying the 5th is to recognize the scale of the challenge. the staggering scale of the challenge. That's what Staffan and I have been talking about today. The reason we wanted to begin this 2-day conference with a technical presentation, if you like, and thank you for bearing with us, numbers, data, charts, and so on, is because it's easy to talk, but when you transfer from talking to doing, kind of paraphrasing Yoda a little bit, when you transfer to talking to doing, you have to look at the data, and the data are staggering. We know how to do it, I think, but we have to mobilize these 5. We have to really focus on the details, and that's what the next 2 days are about. We look forward to, I think, maybe 15 minutes of Q&A before we move on to the next segment. So there's a roaming microphone. I'm actually saying things I don't really know to be true, but there is a roaming microphone that is roaming around if we have some questions that people would like to ask. Where is our roaming mic? Oh, there it is. There's the microphone. So right up here, please. Tell us who you are, and wait for the microphone, though, because if you don't do it without the microphone, we won't hear you.
I understand. Thank you.
Yeah.
My name is Harsh Hashemian. I'm president of AMS, a nuclear engineering company in Knoxville, Tennessee, the United States. So thank you for an excellent presentation, both of you. Thank you very much. What is your assessment of where we are with the advanced reactor development around the world?
Do you want to say that?
Well, it's a very broad question, and I think we can all applaud our friends in China commercially putting HTRPM, their advanced reactor, into operation yesterday. It's been critical for 2 years, but finally in commercial operation. So we're seeing the start of this industry, I would say. It remains to be proven. It's this decade, essentially, is make it or break it. There's, I don't know, 15 or so serious concepts out there. Well, it's too early to tell, but I'm optimistic.
And let me just say a couple words about this. There are 15 serious concepts, there are 40 press releases, and there are a few projects that are moving forward. Let me just answer your question from an investment point of view, which is the number one thing I'm watching on these projects is who is a reliable off-taker, who's really willing to pay reliably for the services. And we've seen in the United States a number of projects crater, one in particular just in recent weeks, because of the inability to focus on that core financial reality. And that's how we're going to make the advanced reactor designs, I think, a success. Another question. The goal is Sama. We have a microphone. You're going to lose your microphone. We're going to take it over here to Sama.
Thank you so much, David, Staffan. That was a very excellent presentation. I think it's, as you both said, it's fabulous to actually see the numbers and come to terms to the size of the challenge and the urgency of the challenge. So I want to focus perhaps on one thing that you mentioned, and I know we will discuss more this week, and is how we mobilize this finance. I think that when I talk to my colleagues in the global nuclear industry, they are ready to do it, but we need, it is a chicken and egg kind of thing, right? So the industry wants to grow, but it needs to have the backing to actually do that. How do we start to get this pebble rolling down the hill?
I find on the financial side, it's helpful to distinguish between two kinds of projects. There are projects that are advancing in places that know how to commit capital to very large projects, even if those projects are first of a kind or risky and so on. Baraka is a great example. What's happened here is incredible, and it's a model. It's a model with a non-Russian export reactor design that could scale. The world should pay attention. These are countries that know how to mobilize capital, whether it's done with state firms, it's done with private markets, in this case Baraka, in the case of blended of the two. To me, the really big challenge, though, is the emerging economies that I showed there. Because there, the financial fundamentals are really unattractive for capital-intensive options. And everything that's interesting in deep decarbonization is capital-intensive. And so, here we are in a world where interest rates are high, where the risk spread between the Western and other countries, that risk spread has grown. And we're going to need solutions like blended finance that may or may not scale. And I think we're in the early stages of really showing how those financial models operate in a world where you have to borrow money in non-local currency, and you have to deal with a variety of other local policy and other risks. So that's, I think, a huge challenge. We've actually known about this challenge for a long time, and it's mostly a finance issue, not so much a technological issue. Other questions? Right here. Oh, and I see, and now we have clock, so we have 10 minutes, so we're in the speed round. I think somewhere there, I see a hand, and the hand needs to be married to a microphone. There we go.
Hello. So, Guillem Sanchez, nuclear engineer from Barcelona, representing here Spanish environmental group Econucleares. For Staffan, so we've seen two sectors, and I'm sure of many, which are great opportunities for growth. We've seen steel data centers. I would ask, what are you looking at as early indicators of progress or success of the deployment in these fields and others? Thank you.
So early success in transforming these sectors. So David had a slide in the beginning saying people are very prone to pledging things, maybe less prone to delivering on those pledges so far. I would say I'm quite encouraged by the steel sector actually going with their pledges, at least in part. So we have some leaders that are actually out there doing it, let's say, and the steel sectors, the mining companies and the steel companies are investing in these kind of transitions. The main blockage for them is not they're investing in their processes to decarbonize their value chain. Their essentially only major impediment is energy supply. So they can only move as fast as energy producers can provide them with clean energy. But they are stepping up. So just in my home country, tiny country of Sweden, there's an investment plan that's already being executed upon at least $40 billion going into decarbonizing the steel value chain. But what's holding up their progress is transmission grid expansion and primarily not enough clean electrons. So it's up to the clean energy industry to help make, if the clean energy industry delivers the energy, these sector transitions will happen, because on their side, they're willing to go for many of them, I would say.
Yeah, and one of the things that Sweden has done so successfully is assured that if these projects are successful, that there will be a demand for clean steel out at the back end, even if it's more expensive than its non-clean rivals.
There's a huge demand already.
Yeah,
there's something called a green premium, which is the expectation of the product being slightly more expensive, at least to beginning with. Has not slowed demand. Demand is enormous for clean steel.
There's another hand right there that needs a microphone. Maybe, sir, if you have the microphone, do you still have the microphone? Oh, you lost the microphone. I'm not entirely sure that I'm in charge here, but that's microphone right there. Perfect. Thank you very much. And then let's give them the next.
Hello.
Yeah, perfect.
Hi, my name is Letitia Cash. I'm with the Safer Cleaner Planet series. Hi, David. Hi, Staffan. We know each other from the past. My question to you is, obviously now we're at COP, so to have nuclear net zero in the climate action debate is groundbreaking. So thank you so much for doing that. My question is about first-of-a-kind investment. I noticed on the countries list, UK wasn't very high up on that, but we are obviously very focused on that with Great British Nuclear. When it comes from the point of view of private investment working with governments on sovereign guarantees, what do you think are the key takeaways on reassurances for the private sector when it comes to first-of-a-kind projects?
I think I'd pay attention to two things in particular. One is the demand for the product. I think one of the successes the UK is having is assuring in the market some reliable demand for that. The second is a guarantee, maybe not 100% guarantee, but enough of a guarantee on the financial side that as you do a first-of-a-kind project and it takes longer or it's different than you originally expect, that the entity that is exposed to that risk is kept whole. The moment the markets see the entity is not going to be kept whole is the moment the markets see risk, and then your cost of capital goes up. This becomes a harder thing to finance. there are a variety of patches you can put around it, but whenever you're putting patches around a project like this and the markets smell that, they're going to see risk. And so those are the two things that I pay closest attention to. We have time for still some more questions. Where is it? Okay, there's a microphone. Perfect. Sir, and then we're going to eventually get the microphone up here. So if we have a second microphone, let's pre-position it over here so we're ready to go. Sir.
Yes, Jeff Merrifield with Pillsbury Law Firm. Your slide on inertia was quite impressive. Do you have more information about the trending of where those lines are going, number one? And number two, given that kind of information, how can we do a better job of getting that message out to the electricity regulators who can really make an impact on helping improve what is a poorly trending trend?
So we should, again, plug that together with Mohammed Al-Hamadi, we published a paper on this, kind of charting that trend and seeing where we are at now and where we are headed. We had two use cases, the Nordics and the UK, but actually it's quite applicable everywhere. It is a bit of a communication challenge because these things are not readily explainable to a lay public. So we have made some efforts to try to make this more easily explainable, including some animations about how inertia actually works. But we are just at the starting point of trying, not just we, but as a society to understand this challenge, and how big it's going to get. So I don't know if that's a satisfying answer, but we are trying, essentially the communication challenge is to explain it in terms where people don't fall asleep while you're trying to explain what inertia is, and you don't really get to explain why it's a problem. We are actively working on that, but anyone who wants to join in that effort are warmly welcome.
As we move to the next question, I want to say one more thing about regulators. Is the microphone already over here? Yeah, so I want to say one more thing about regulators, which is I think the regulators who focus, and policymakers who focus on bulk energy supply don't really get this. The ones who are focused on grid reliability get it all around the world. And they know that the reason the National Academy of Engineering listed electricity as the most important innovation of the last century is because of affordability and over time cleanliness and reliability. And they recognize that if you fail on the reliability front, that's politically catastrophic and economically catastrophic. Next question.
Thank you, Raf Sholoma from the MCC Budapest. Thank you very much for mentioning AI and data centers. I think this is very underestimated and very important. And you also talked about the production of steel. Now, if we go one step back, what's your take on mining? Because I think if we want to meet these challenges, we're probably going to need more energy sources of all kinds, which probably will also need more mining in the future. And is there a way for quote-unquote clean mining, or will this be another problem in the future?
My take is clean mining is a far easier challenge to solve than clean steel production. The energy demand for, say, battery or even catenary mining vehicles and mining equipment is far lower, and that's already happening. There's electrified mines already. But one challenge with, say, the environmental movement is a bit of a disconnect between the needs for new mines and new mining and new materials and the inherent resistance to mining from the environmental community. This is a bit of a challenge. We are saying we need to mine more iron ore, for example, to, for example, build windmills. You need materials to build the clean energy system of the future. And there's a communication challenge of mining, which is seen as something environmentally destructive, actually enabling an environmental transition. So that is an ongoing challenge to all of these plants, actually.
Yeah. We have time for one more question, but I just want to assure you that although there's been a lot of progress in AI, we are both real. We are not bots. This is a real talk. We're real people.
We would be far more eloquent if we were AIs.
Maybe. I don't know. Let's not sell ourselves short here. Last question right here.
Hi, Shirley Rodriguez, Booz Allen Hamilton, ARPA EDOE. My question, I have two actually. So the first one is, right after the announcement of tripling nuclear energy, it was 110 countries about tripling renewables. How do we approach when it comes to investment, knowing that nuclear will need more? And the second question is, okay, tripling nuclear energy. what about advanced energy? How are we going to foster an environment in which also advanced nuclear is part of that tripling nuclear energy? Thanks.
Want to say something about this?
Yeah, so as I said, I think we were talking about pies earlier. I mean, there's enough out there for both pies. And I would say the 22 countries that signed up to tripling nuclear represents the vast majority of energy demand, China hopefully joining as well. I think David's touched upon it. I mean, one of the major hurdles that is being worked on quite well now is the cost of capital. I mean, that is the main hurdle. And so there is a private-public connect there where, for a while at least, the public, politics, governments will need to de-risk to get the cost of capital down, because that is, you know, for a new nuclear project, could be more than half of the total cost. So the enabler is what's being done politically now, I think, at least in Western Europe. So we have the Swedish Vice Minister for Climate here has just launched initiatives aimed at lowering the risk of investment in nuclear, at least for a transitional period. The UK is doing similar things. Those are probably the kind of pathways you can do if you're not blessed with the circumstances of, say, the United Arab Emirates.
We need to move on to the next session. Let me just say very briefly, markets are good at doing what they know how to do. And one of the lessons from our presentation today is we need a diversity of sources, including the things that are not as familiar, but the value of diversity is very high. I want to thank all of you for your attention this morning. We're going to move on to the next panel.
Thank you.